Okay. All right. Hey, Vibhu, how are you?
I'm good. How are you?
Very good. Yeah. So, do you want to introduce yourself?
All right. I'm Vibu, and I'll be going to university this fall.
Cool. Awesome. Congrats.
Thank
Yeah.
you.
So, what I will be or what we will be doing is I'll be taking you through the basics of finance and investing over maybe 3 or 4 recordings. We'll see how long it's going to take. So what I'm going to share is something that I started learning when I was 28, and you're getting to learn the same thing at 18. And happy birthday to you! And today is your birthday, right? So yeah, with that, I'm going to get started, and I'm going to stop the camera. Okay, so we are off camera now. Okay, so let me put it in presentation mode. Okay. So the first session that we will do is on, it's called as the joys of compounding, as you can see here, where I will be explaining you the power of compound interest or compounding in general. I'm sure, right, you would have studied compounding in your 7th grade, but you'll be seeing it in a different light in this session. Okay, so let's start with a simple question. What happens if you fold a piece of paper 45 times? So imagine you have an A4 sheet, a white paper in your hand, and let's take you fold it in the middle. That's one fold.
hmm
And you fold it again. That's two. What happens when you fold it 45 times?
I mean,
How,
it gets pretty tall.
how tall?
How tall? I mean, every time you fold it, it's like double the previous size. So,
Yeah. So maybe just make a guess.
I mean, it grows exponentially,
Yeah.
right? So, I don't know. Maybe I could say 2 to the 45th power,
Oh, yeah.
and 2 to the 45th of like the original height times the original height.
Yeah. So which means you need to know what the original height of the paper is, right? So the
Yeah.
paper height is 1 divided by 1000 centimeters, which is point not 1 centimeters. So times 2 to the power 45, right?
hmm
Okay, so you are absolutely right. So there's a video, it's an excellent video that shows you what happens when you fold a piece of paper. So what happens is on the 45th attempt, you would pretty much reach a moon from Earth to moon, and you fold it one more time, you can come back to Earth. Okay, so I won't play the video here because I'm not really sure of the copyright violations. But what I have done is, right, I just did some math on this sheet. Can you see the sheet?
Yeah.
Right, so when we start, it was, as I said, right, point not 1 centimeters. And roughly, right, how much is how many centimeters are there in a kilometers, because it's easy to deal in kilometers after a certain
Um,
points.
I mean, I know there's 1,000 meters in a kilometer, and
Yeah,
there's 100 centimeters in a meter. So if you multiply those together, I believe it's 100,000.
yeah, it's
Yeah.
100,000, right? So what I did a conversion over here, and I'll explain what distant covered column is at the very end, right? So the first double, so fold, I mean, without any fold, the paper thickness is point not 1 centimeters. Fold one, it goes to point not 2. Fold two, it goes to point not 4. Sorry, point not 2, point not 4. All the way on the 45th fold, it is 335 billion niche centimeters, which translates to 351,844 kilometers, which is almost like, say, 91, 92% of the distance to moon. Okay, right?
hmm
So the key here is, right, if you look at the first 10 folds, what is the total length of the paper that it got added up to?
it's like 1 centimeter.
Hardly anything, right?
Yeah,
At 20, how much did it what would be the height of the paper?
it's 1,049. It's like times 100 about, or 1,000.
Yeah, 1,000 centimeters, right? So how much is 1,000 centimeters?
How much is it? I
How
mean,
can you visualize 1,000 centimeters? I mean, that's one habit, right? That it's always good to visualize numbers. So what comes to mind when you think of 1,000 centimeters? Maybe just convert it into meters. How many meters would that be?
all right. I mean, that would be 100,000 meters. Well, I
Yep.
mean, that's pretty big because
No, 1,000 centimeters will be 10 meters,
Oh
right?
yeah, 10 meters. Right.
As you divide by 100.
Yeah.
So roughly, right, if you look at a bowling lane, it would be 20 meters. So 10 meters would be half of a bowling lane, right?
Hmm.
So the reason I'm giving you that visualization is it's always better to look at something concrete whenever you compare it with a number, so that the number sticks with you a lot longer and you would develop an intuitive feeling of numbers, right? So now if you look at what I did was, right, this column, let's talk about column distance covered. I'm just dividing the column C, which is kilometers, divided by the final kilometer, right?
Hmm.
Just seeing how much distance did we cover on, say, on each of the fold. If you look at up to fold 10, not much, because I've just rounded, removed all the decimals, hardly, not even a
Yeah.
kilometer we traveled, right? Even on fold 20, hardly anything. Fold 30 is nothing. Now look at fold 40, okay?
Hmm.
3% of the final distance got covered in fold 40. Now look at the gap between fold 40 and the next 5 folds got you to 100% of the distance covered.
Right.
What do you take away from this?
I mean, it's starting to increase faster as the number of folds increases. Cause like in the first like 37, it's still at around 0%.
Yeah,
But in the last like 5 folds, it increased by 97%.
exactly. I think what if someone, I mean, folding paper would not be the best example, but let's talk about it, right? What if someone, left on their 30th fold or 35th fold? Nothing material would have happened. But let's take after 38 fold, they are starting to see like, oh, maybe I covered 1% of the distance. I covered 3%, then it's 50. And the last fold gets you that 50. So which means, right, maximum results happen at the very end in compounding, right? I mean, as you said, it's an exponential function. It's a key takeaway to remember. Got
All
it?
right. Yeah.
All right, moving along. So let's talk about what happens if we get 1% better every day. So what do I mean by getting better? Say, for example, the habit of uh, reading, habit of exercising every day, habit of eating healthy every day, right? These are all habits, and that's what I meant by getting better 1% every day. Let's take ours at 100. Tomorrow I might be at 101, then I'm getting 1% better. So what happens if we get 1% every day? And I'm going to show you another comparison where what happens when we get worse 1% every day, right? And if you look at the results, it'll be mind blowing. So take a look at this, right? This is, I got this from a blog called as jamesclear.com. So the chart that you see, the exponential curve up, you see that's getting 1% every day, 1.01, which is 1% to the raised to the power 365. Because you keep doing this every day, and then for 1 year, you would have gotten better by almost 38x. Okay. Now look at the
Hmm.
second example. What happens here?
I mean, you get worse by 1% every day,
Yeah.
and you decrease your you decrease by 0.03x, right?
Yeah, I mean, you go down to almost zero, right? The difference
Yeah.
between the first and the second is mind blowing, and the chart below clearly shows the one that is curving up, and the one below it is curving down. See, both are exponential, but the difference is the first one is on the better side, and the next one is on the worse side. Okay,
Right.
right. What's common between folding a paper example and getting better everyday example?
I mean, most of the results show in the long run.
Yeah. What else? What math concept?
Oh, they're both exponential.
Yeah, both are exponential, right? Do you remember this math that you learned in seventh grade? Possibly. I don't know. When did you?
I mean, I don't know which year we talked about this, but yeah, it's this sounds familiar.
Yeah. Cool. So basically, this is the C. I mean, it's not a secret, right? Compound interest, and if you remove interest, right, the concept of compounding or exponential functions is key to so many great things in life, and it is also key to so many bad things in life. The question is, how do we use it to our advantage so that we get benefited by compounding, right? Now, if you look at the formula, right, A is the final amount and P is the initial amount, and 1 plus R, forget the N, let's keep N for 1 now, the whole power T. So in the paper example, what was P?
The starting.
Yeah.
I forgot what was the length,
Yeah,
the height again?
point, not one, 1 divided by 1,000 centimeters.
Right, that would be the principal.
Yeah.
The rate of interest would be, it would be, it's since it's double, what would it be? Would it be
1, right?
one, right?
100%.
Yeah, yeah.
So it's 1, and so 1 plus 1 is 2. This is where the 2 came from.
Mm-hmm.
And then what was the numerator?
The number of folds.
Yeah, which was 45, right?
Right.
Now in the getting better example, what is P? For on getting better every day, what was P?
It was, I had one, right?
Yeah,
You
it was
start at
1.
one.
Yeah, and what was R?
R was 0.01.
0.01. Yeah, that's right. So that's why it's 1.01, right?
Yeah.
And then what was the power?
I don't think that was given any. Oh, 365, right?
Yeah, it was 365 because we are getting better every day, right? So
All
what
right.
happens N here is, right, the number of times compounding happens in a year. So that's why it is 300, and so we said every day 1%, right? So and the whole power becomes 365. And
Right.
then in the worst example is 0.99 is what you started with. And and it's the same, the whole power, sorry, you started with 1. Given that R was minus 0.01, it becomes 0.99, the whole power 365, right? So basically that's what happened. Okay, now I'm just going to show you, I'm going to jump into the Excel sheet and I'm going to explain you the magic of compounding when applied to money. Okay. So here's a simple example, right, that I took. So let's take, I have $27,500 with me. All right.
Mm-hmm.
And the rate of interest is 6%. And every year I'm going to add 27,500. So let's take, every year on the 1st of January, I'm going to add 27,500 extra.
Mm-hmm.
And I'm going to do that for 20 years. Okay. Right?
Yeah.
So how much did I contribute overall?
It shows row 6,
Yeah.
577,500.
Yeah, exactly. So what we did was 27,500 times 20 plus the original 27,500, right? So
Yeah.
like 575,000 and change, or $577,500 is what our contributions are. But how much did the total value come out to be or turn out to be?
Yeah, it's 1,160,496.
Exactly. So, which means, right, that the excess that we are talking about, when I say the excess, which is what we put in, for some reason, okay.
Like how much your money grew by?
Yeah, how much the money grew by, right? We in fact more than doubled how much our original contributions were, right?
Mm-hmm.
So this is where the magic of compounding comes in, and I'm going to break it apart, right? So what I did, using another number as an example to show you how much compounding is adding to the final wealth. So in this case, how much are we starting with? $6,000, right?
Mm-hmm. Right.
Rate of interest is 6%. Every year, I'm adding $6,000 to it, and then we are going to do it for 30 years. Okay.
Right.
Now let's move to this chart. Year 1, 6,000. Okay.
Mm-hmm.
6,000 compounded at 6% over 30 years. How much did that 6,000 chunk grew up by?
It grew up by almost
Yeah, close to 6x, right? 6,000
yeah.
becomes close to say 36,000. Now the next 6,000 is yielding you what, 32,500.
Yeah, about like 5 times, a
Yeah,
bit
it's
more than
5
that.
times, right? So now if you look at the overall future value, it's what, $502,810.
Mm-hmm.
How much did we contribute?
180K.
And what is the excess?
About 322K.
Yeah, and where is the excess coming from? Where, let's add up
It's
the
for,
first 5 rows, right? This
yeah.
is the first 5 rows. How much did this add up to? You can look at it at the bottom here.
Oh
One,
yeah. Oh right, it's under. Yeah, about 123K
yeah,
thousand.
yeah, roughly let's call it as 125,000.
All right. Yeah.
So pretty much you're out of the 322 810, or let's call it as 322, right? So if you do this math, simple rounding math, close to 40%, right,
Mm-hmm.
came in the first 5 years. Okay,
Right.
think about it. The first 5 and 30 years contributed to 40% of the difference, or contribute 40% of the difference, right?
Right.
So what is the key takeaway that you can get from this particular slide?
Well, I mean, if you start early,
Yes,
it
yes, it
grows a lot more.
a lot more. And what's the difference between you and I said when I started this presentation.
I started learning about this about 10 years earlier.
Yeah, you're 18 and I started knowing about all this when I was 28, and that's when I think, or I remember making my first investment. Now you have a 10-year advantage, and as I already told you, the 5 years of 30, right, how much is it? 16% of the time added up to 40% of the wealth. So as you said, right, you pretty much nailed it, which is the earlier you start, the better it is. Okay,
Mhm.
now let me jump back to this slide again. uh, okay, now here's a quick rule of thumb that I'm going to teach you. I don't know if you already know. If so, let me know. So if I tell you the rate of return, let's take if you are going to compound your money at 10%,
Mhm.
then using this formula, say 72 divided by 10% will be, say, 7 years, right? Roughly. So
Yeah.
it'll tell you the time taken for the money to double if you know the rate of interest, and vice versa. So let's take, I'll give you a few other examples, right? Let's take it takes 6% interest compounding. How long would it take for the money to double?
I mean 72.
Yeah,
I mean, you
72.
just do 72 divided by 6,
Yeah,
and that gets you 12 years.
yeah. What about 9%?
Yeah, 72 divided by 9, that gets you 8 years.
72 by 8%.
Oh, 72 by
Yeah,
8%. Oh, yeah, 9
9
years.
years, right? Yeah. So the reason I'm telling you, right, always remember, right, whenever possible, if you can somehow summarize a key idea into a back of the envelope calculations, it's going to make you a lot more smarter, and you would be able to connect dots a lot more easier, right? So I'll give an example where when I talk to a lot of my friends, they will say like, oh, you know what, I give my money to someone else to manage and they just charge me 1%, just 1%, right? So that's how the conversation started. And then I give them this example. So let's take let's take you're getting 9% interest, right? Or
Mhm.
9% return. How long would it take for that money to double?
8 years.
8 years, right? So let's take you are going to invest for 40 years. How many doubles you're going to make? You're going to get
If you invest for 40 years, that's like 5, right?
5 doubles. How much is 5 doubles?
5 doubles. Like, what do you mean by how much is? Oh, like 72 times 5.
No, no, 2 power 5. Five
Oh,
doubles,
right.
right?
Yeah,
Yeah,
yeah. It's because doubles every time.
yeah.
Or yeah. So yeah.
That's what 2 power 5 is. How much?
2 power 5.
32,
Yeah, 32.
right? 2 times 2 times, yeah, into 5. Now let's take, you give your money to someone else to manage and they take 1% of that. Now your 9% becomes 8%. Okay.
Hmm.
And how many years would it take to double?
If it was 8% would become 9 years.
9 years. Now, how many, if you're going to invest for 40 years, how many doubles would I get?
That's not going to be exact, but
It'll be for somewhere between 4 and 5, right?
yeah.
So that'll be like around 4.4. Rough mental math is, right?
Right.
So your money, if it is 4 times 4 doubles, how much would your money grow by? $1 would become.
Um, Wait, repeat the question.
So 4 doubles. Let's take I
Hmm.
start with $1.
Right.
Get 4 doubles because in the 8% example, money doubles a little over 4 times. But let's do a rough math to say how much would 4 doubles yield me if I start with $1.
How much? I mean, would it just be two to the fourth power?
Yeah, which is
Two to the fourth power is about 16, right? Yeah.
16, right? Now in the case where you managed it on your own, it became 2 to the power 5, 32, right?
Mm-hmm.
And roughly we know that 40 divided by 9 is not 4, it's a little over 4. So roughly let's take it's 4.4 or 4.5. So your money will grow by 21x compared to 32x, right?
Right.
Which means you are giving up 30% or 35% of what you would have gotten. Think about it, just that 1% difference, you are losing 30 to 35% of your money, you're giving it to someone else. Okay,
Mm-hmm.
is that clear?
Yeah.
So the reason I'm saying why this quick mental math is going to help is remember, right? We do a lot of things in life, and every time you have to pull up a calculator or an Excel sheet or a Google Doc to compute all of these things, you won't do it. You would just be like, "Hey, I'm not going to do it. This is too much of work." But if you can simplify it to a formula like this, some of the key ideas, then you can do a quick math and say like, okay, I am not going to give up that 1% because that 1% at the very end is going to let me lose 30 to 35% of my net worth or whatever I'm investing in, right? Why would I do that? So this is something to take away from this. Clear?
Mm-hmm.
Any questions on this?
None so far. It all makes sense.
All right. Now, remember, right? I mean, we already spoke about it. The concept of compounding is backloaded, where the paper folding example, up to 40 folds, nothing much happened, right? Or up to 37 folds, nothing much happened. Then
Mm-hmm.
the magic started happening from 38 to 40 to 45, where the benefit from compounding happens at the very end, not at the early stages. And if you remember this example, the benefit goes to the piece that started much earlier, right? These two
Right.
are going to get the most of the benefits at the very end. That's what I mean by compounding is backloaded. And the benefit is going to go to those pieces that started way earlier compared to the pieces that started at the very end. Look at the last 5, right? So
Mm-hmm.
26 to 30 over here in this example. How much
Yeah.
does those 5 years add up to? It's like 5,852, right?
Mm-hmm.
The 8, right? That's hardly a rounding error to 322, 810, right?
Yeah.
So the last 5, even though is the same in terms of the time span, but they hardly added anything compared to what the first 5 added, right? So that's why
Yeah.
compounding is backloaded. This sheet has another example, $1 invested at 15%. Now apply the formula. At 15%, how many years would the money double?
It would be 72 divided by 15,
Yeah.
and that would be around 5.
Yeah, just round it, right? You don't need to be precise 5, right? So
Yeah.
look at, we started with 1 here. What happened at 5?
It doubled to 2.
10.
Doubled.
Doubled at 15.
Yep.
Doubled at where? 20,
20.
right? Now here's the
Uh-huh.
kicker, right? Look at the last 5 years, made you $8, right?
Right.
Half of what you got happened in the last 5 years,
Mm-hmm.
right? So that's what I mean by, again, another example where I wanted to stress why compounding is backloaded.
Right.
Cool. Questions?
No, not yet.
All right. Moving on, right? So the slide that you see here, this is about all the US households, right? So roughly US has 330 million people, in the United States.
Mm-hmm.
And if you take a family of three, roughly there should be around say 120 million households, right?
Yeah.
So this chart shows the debt, non-housing debt that are owned by all the households in the US. These are people like us, people like our friends and families, right? What do I mean by non-housing debt? So there are two kinds of debt, right? Say if we want to buy a home, we can
Mm-hmm.
take a mortgage. That in the sense we can borrow from bank, and that's called as a mortgage, and that debt is called as a housing debt, right? Now I can borrow for things that are not related to buying a home or buying a house. Those kinds of debt is called as non-housing debt. What are some examples that come to your mind that are non-housing related?
Well, I mean, one big one is like the credit card loans if you don't pay it in time or don't pay enough.
Yeah, and then what's the biggest in the chart that you see?
Student loans.
Yeah, student loan, right? That's like what, 1.58 trillion.
Yeah.
So if you add it all up, right, how much would this come to? This will roughly be, I'm just looking at the speaker notes that I have. This
Uh,
should, okay, so the total US household debt, it's like people like us, our friends, families, right? All the consumer, all the people, right, in the US, the consumers, they have borrowed close to $15 trillion. Okay.
mhm.
Of this 15 trillion, say close to 30% is related to non-housing, and say 70-ish% is related to housing. Okay.
Right.
Now, why am I showing you this slide? The reason for that is I can understand if for of all these debt, right? I can understand why people take auto loans. Say, for example, if I'm going to buy a car, not many people can afford to pay it all in cash. And car is something that we all need on a daily basis. It's a utility. So I can understand why borrowing for an auto loan is important, right?
Mhm.
I can say the same thing for student loan. Not every student or kid in America, they are lucky enough to for their parents to fund their education. It's not easy, right? Money is not easy to come by, so they have to go and take student loan. And that also I can understand. It's like 1.58 trillion. And then the other category, I don't know what they are. That's say 410 billion or 0.41 trillion, which I can understand. But look at the credit card debt. How
Oh
much is
yeah.
this?
0.77 trillion.
Yeah, or say 770 bill, right?
Mhm.
So why would so this is something, right, where I'm trying to understand why do people borrow on their credit cards? Do you know how much they pay when they borrow on credit cards?
I mean, I know the interest fee is like pretty high, like 26% or something.
Yeah, it
Like it has
depends.
like,
Yeah,
yeah, it depends on the card.
yeah. Or you for where did you read it as 26%?
I mean, in business class we talked about like credit card loans and all, and I mean, I think one of the examples was like 26%.
Got
I
it,
might
got
be
it.
like, yeah.
No, no, no. I think it depends on the card, as you said. I think the average is between say 15 to 17%. But that's average, right? But the extremes can be much, much higher. And there are two kinds of credit card holders. Those who pay it all in full at the end of every cycle,
Mm-hmm.
they are called as transactors. So they don't pay anything on the card. So the card is free for us, and then we pay it at the end of every month. So let's take at the beginning of each month, right, is where our cycle comes in. So we pay it, we don't pay any charge. But for those who keep balance on the credit card, they are called as revolvers. So they have to pay interest rate on these credit cards, and that interest rate is around 15 to 17%. Okay. So the reason I'm stressing it so much is of all these loans, I think credit card loan is something that can definitely be avoided. The
Oh yeah.
reason is why would you pay 15 or 17%, right? So I'm going to okay. So this is a chart that I got some time back, and it stops till 2019. So this is the percentage of households who are revolving credit card debt. In the sense I told you, right, there are transactors who use the credit card every month and pay it in full at the end of the month or at the beginning of the month, depending on their cycle. But there are others who are revolvers who keep balance and they pay interest on the balance. So roughly, right, I would say somewhere between 35% of the households to 40% of the households in the US, they keep credit card debt, which means they pay interest.
Right.
Now, do you want to know how much it's going to cost them? So I just constructed a simple model. This is just for example. The actual credit card calculations might be very different, but let's take a look at it, right? So here is Alice.
Mm-hmm.
Alice has a credit card debt of say $6,000. So Alice is paying an interest of 15%. I just took 15%. And let's pretend, right? Because in real life, nobody is going to do this 240 months. 240 months is what, 20 years, right? I just took it as an example.
Right.
So if Alice keeps a $6,000 debt continuously on her card at 15% for 20 years, every month Alice is going to pay how much? $79, right? This is
Mm-hmm.
I mean, credit card companies, their math could be very different. I'm just using a simple back of the envelope example here. So Alice is going to pay $79, right?
Yeah.
But during the entire period, Alice would have paid 79 times 240, which is like close to $19,000.
Mm-hmm.
How much was the interest paid on the debt of
Uh,
6,000?
pretty much 1,300.
1,300, 13, I mean
Oh,
$13,000,
13,000. Yeah.
right? Now
Mm-hmm.
let's take another person, Becky,
All right.
who's going to save money, right? Where they are transactors, not revolvers and credit card. So they are paying, so this person, let's take, they, instead of taking a debt of 6,000, they used that 6,000 to invest in something that is yielding them 6%. Okay.
All right.
Now they are going to do it for 20 years. Why 20? Remember, I just divided 240 months by 12 to get 20 years.
All right.
Right? Number of months is 240. You divide it by 12. Every year has 12 months. You get 20 years. Now, where did I get this $948 addition? Remember, if I'm paying $79 every year,
Mm-hmm. Oh, yeah. If you multiply that
yeah,
by.
yeah. So I'm going to get 948. Now, during the same time, how much would Becky have earned?
Um, I mean, in
1,000.
total, it's
Yeah.
yeah, 56,000, and but like it grew by like what 25,000.
Yeah, the compounding effects are like 26,000. So two examples, one person is paying 13,000 over here and the other person has gotten 25,000 right on their bank account, or let's take in a brokerage account. So the opportunity cost between Alice using a credit card and Becky who is saving and investing is huge. Like, why would you pay someone just so that you can spend a little more or a lot more and rake up in credit card debt and end up paying 15% on that? Rather, you are paying 6%. If you run it at the same 15%, look at the opportunity cost there. That's
Oh yeah.
close to $210,000. I'm just lowballing it to 6%. We'll talk about 6% in one of the future sessions, why I'm putting 6% and not 15%. But just look at the opportunity cost is huge. Right? Again, these are rough math. This is not how credit card company math will look like. It's going to be close enough, but this is as an example to show you why credit card debt is not a good debt. You can't win by running at 15%. In the sense, you will lose a lot by running at 15%, where you'd have to pay that 15% to someone else every year. Questions on this?
I mean, just like a comment, it's kind
Yeah.
of like I don't know. It's kind of like surprising. Like if you like they have like this minimum fee you have to pay, but it's kind of like a trap to get you to pay like a lot more.
That's correct. Minimum for whom is maximum for others, right? Minimum for you is maximum for
Ah, yeah,
the yeah.
that's a good way to look at it.
Yeah, it's minimum for whom, right? I think that's the question to ask. So the opportunity cost is massive. So that's an important lesson to take away, right? Again, not every debt is bad, but again, I have chosen to operate without any debt. But I just wanted to give you a flavor of how to think about it. And that's what I said, credit card debt kills compounding.
Right.
Cool.
Mhm.
All right, we are getting closer. Do you know who this person is?
Yeah, Charlie Munger. Isn't he one of the Berkshire Hathaway like
Yeah.
CEOs or leaders?
Yeah, he's the vice chairman. He is the,
Chairman.
yeah,
All right.
vice chairman, the right hand guy for Warren Buffett. Yeah. So I think his quote pretty much summarizes what I want to share in this session, which is to spend less than you make, always be saving something. Actually, I would say like always be saving and investing that something. Put it in a tax deferred account. We'll talk about it later, or we spoke about it today morning on tax deferred accounts a little
Yeah,
bit.
like isn't a 401k also like
That's
a
right.
yeah.
That's right. And over time, it'll amount to it. It will begin to amount to something. This is such a no-brainer. Remember the Becky example, who was saving and investing,
Yeah.
compared to Alice, who was pretty much paying it to the bank, which gave her the credit card.
Mhm.
So it's such a no-brainer. Such a no-brainer. One has to follow. And the last thing is this is a book by J.L. Collins on the simple path to wealth. So remember, I read this book maybe very recently, because it came out, I think, in 2019, if I vaguely remember it. There is a YouTube video by this author, J.L. Collins. He explains these concepts so simply, where all you have to do is to just listen to it. And if you get a chance, read this book. You will start to gain so much of clarity and wisdom when you are 18, compared to when I started learning about all this when I was 28. With that, we conclude part one. Any questions you have?
No, I thought this was a pretty like well explained presentation and I understood like all the concepts.
Awesome. Okay, so I'm going to pause the recording. That's it. Thank you everyone for patiently listening.